So let's continue our debugging session. So far we have play count equal 3, and the first ping call is on the stack. Again, I'm going to press F11, which will allow me to step into this next call, F11, and you see that function just called itself. And this time play count that it shows as a local variable is set to 2 because it was it got the value of 3 minus 1. And notice that the new ping function call, the new stack frame for this function call just appeared on the call stack. So now we have main and 2 instances of ping stack frames on the stack, which is fine. We already predicted this. So I'm just going to press F10 a few times just to step over everything I have over here. And I'm just about to make another call into ping, another recursive call, the function calling itself. And again, I'm going to press F11 to make sure that I will see what happens inside this function call. So observe that the current play count minus 1, when I make this call into a new instance, and look, there's the the third time the ping is being invoked during our program execution, and the play count becomes 1. So I'll fast forward it by pressing F10, F10, and now again F11 to step into the function call the 4th time. So one more F11 press on this line. So normally I press F10 to step over lines, but when I anticipate that I want to see something happening inside function call, I press F11, which allows me to step into the function call. So F11, so this is now the 4th time we're invoking the same function, but with a different parameter, F10, and you can see that the play count now is set to 0. Okay, so this debugging environment shows me that by local variables, which is the play count, which is also function parameter, is 0. And so this time this condition should be true, and I press F10, and here we go, we have a return statement. So we pressing F10 now, and as promised, a return statement takes you right to, it's like a jump to the closing brace, because as we have the opening brace that constructs the stack frame for this function, the closing brace is responsible for deallocating that memory on the stack and returning that memory back to the system so that, you know, that memory can be reused in the future. So this is our last 4th, if you want to count the ping call, and we're just about to exit from here. So there we just return back to the ping call that was prior to it. And here play count becomes 1 because this was the local variable when the function was called. We don't even change this play count. The only place where it gets changed, we pass it as a recalculated value to the next function call. So F10, and we're exiting from this call number 3. And now we're returning back to call number 2. And also exiting. So we shrink here on the stack. See how these stack frames are disappearing because we're returning from our function calls. And eventually we're returning back to main. So the next press F10 takes me to the next prompt for how many times to play, right? So if I step over this line, F10, you see that now we're printing this prompt again. And we're just about to return right back to this condition of our loop where we'll be waiting for the next input by the user. So this is our debugging session. You can see that it was quite visible inside the call stack and inside the view of local variables, what happened to the play count and how far did we go with the value entered by the user. So this is our debugging session that actually showed us all the dynamics of these recursive function calls. I'm not going to continue this debugging session because it was just fine to see what we saw with each invocation. We were printing what was expected to be printed. and we observed the dynamics of this play count being handled by these function calls, and eventually when it became 0, we started to return from all of these calls because they were just finishing all of their work, and the only thing that was left in them to do is to just return back to its caller. Now also notice that this integer variable, play count, of course it's a local variable in function main, right? So function main has its set of local variables. Pretty much all variables and objects declared inside of its body become local variables of this function. So therefore, regardless that the name is the same or different, in my case, I just didn't want to invent new names. I already have play count, and I'm pretty satisfied by this name of the variable. So I named it the same way here inside function ping. And you realize that this function was invoked 4 times during program execution. And each time ping was invoked, it was getting a separate copy of play count, because the input parameter is just like a local variable, and the function itself is like a separate universe, a remote island that is free to name its local variables any way it wants. So it does not conflict with any other names that we may have elsewhere in our program. So anyway, this is what I was trying to show you, and so don't make a mistake thinking that this is the same variable as this and as this. The names are the same, exactly the same names, because I simply copied and pasted this name right here. But the variable is completely different. Physically, this is just a copy of whatever was decided to be passed to this function to begin with, right? So we started with 3 because I entered 3, and then it got decremented with every ping call because we were subtracting 1 before making another function call. But local variables and their names have nothing to do with anything named the same way outside of the function call, right? So compiler knows that this is a local variable. The function is expecting input parameter. It will be set to a certain value, and this function will be free to use this value any way it wants inside its body. As soon as this function returns, right? As soon as we say return, remember this return does not take you immediately out of the function. It jumps here. And this closing brace will destroy all of the local variables, including function parameters, because function parameters are also local variables. It's just that they have to be initialized in this special way because they're initialized when the function is invoked, right? So when the function is invoked, a copy of the value is already prepared for this variable, and as soon as the function begins to execute its body, this variable is ready to go. It already has a name, it has its own memory allocation, and it has its own very well initialized value upon entry into this function. And once again, functions can call themselves. And that technique could implement iteration, or it's an alternative to a loop. And it's a very elegant solution because it just works. As you could see, we were entering these numbers here, and everything proceeds as expected. So this is a very powerful technique, and it's a great way to learn how function calls work. Because if you don't understand this recursion, I don't think you really understand how function calls work and how function rules apply to the rest of the program. So hopefully, if you need to, you can watch this video again and just watch like everything I did step by step in our demonstrations. So now we're ready to proceed to the next version of our program and see what other interesting thing we can observe in this a little ping pong demonstration.